All right, so I think this is recording. Let's look here. We want to find the exact value for the cosine of 255 degrees. And if we use the calculator, it'll give us a decimal approximation. We want an exact value. If we go to the unit circle, 255 isn't one of our special angles. But we do have these new sum of difference formulas. And on the paper, it gives us a hint. And it says that you can look at 255 degrees as 120 degrees plus 135 degrees. And those are two numbers that are on the unit circle. So we have a formula that tells us that if you have the cosine of A plus B, that's the cosine of A times the cosine of B, and if this is plus for the cosines, it changes sign, and sine of A times the sine of B, or at least that's what I think it is. All right, so we've got the cosine of 120 times the cosine of 135 minus the sine of 120 and the sine of 135. So 120, that's a pi over 3, a 60-degree angle. Cosine of 120, 120 is in the second quadrant, so this is going to be a negative value. And I think it should be negative 1/2, right? The 135, that's a pi over 4, that's a 45-degree angle. It's in quadrant 2, so it's negative also. The y-coordinate of 120, same as that's the radical 3 over 2. Now it should be positive because it's in quadrant 2 and it agrees with the y-coordinate and sine SIGN. And the sine of 135, this is radical 2 over 2, and it should be positive as well. All right, so we multiply these together, and negative times the negative is positive. So we have radical 2 minus radical 6 over 4. So let's check that on the calculator as far as a decimal approximation to see if that's reasonable. We've got, oops, we do have to punch in the right buttons on the calculator. I am in degrees. So for 255, that is in quadrant 3, and both sine and cosine are negative in quadrant 3, so that agrees so far with what we know. This should be a negative value as well, the subtraction. And we'll divide it by 4. So it looks good. All right, so that's my final answer. So I hope that helps, and I will talk to you later. Bye.